Okay, you people who are gone at TVC 1 Act, we're going to start section 3.2 today. Tomorrow is Wednesday. We're going to finish the backside of 3.2 notes. I will be gone on Thursday and Friday, and we're going to do section 3.3 on Thursday and Friday. I'll do half of it one day, half of it the next day. All of those instructions I'll leave for you on Google Classroom. Mr. Johnson will be my sub. Just make sure that you come to class with your Chromebook charged, probably headphones if you use them. But we'll do 3.3 on Thursday, Friday, and I will leave that assignment for you. Okay? But we're going to start 3.2 today just so that we get finished tomorrow, and then tomorrow I can give you guys time in class to work if you need, if you want to do problems in class. There you go.
Is this lesson?
No, it's not too bad. So this is more explaining kind of, you get kind of a visual of what a limit is. So introduction to limits, finding limits graphically and numerically. Tomorrow is, or section 3.3 is analytically finding limits. I think analytically finding limits where you're actually given equations makes more sense than finding them using a graph, because I don't like graphing things. But it is what it is. This section kind of shows you what it means to be a limit, okay? So this function right here, f of x equals x cubed minus 1 over x minus 1, okay? X minus 1, if it's on the bottom, kind of looks as though I have a vertical asymptote on the bottom at 1, right? If you would set x minus 1 equal to 0, x would be equal to 1. It looks as though I have a VA at 1, but it's actually not a VA. It is actually, I'm watching you girls. One of you guys go over there.
Why would you sit that close to taking a second?
I don't know. Somebody bump to the other table. Okay? It looks like it's a VA. No, somebody bump to the other table. Casey, Emma, one of the two. So it looks like it's a VA at x equals 1, but it's not. It's actually a hole, okay? And we cannot evaluate things at holes. Like if I were to try to plug the value 1 in here, I would get 1 cubed minus 1 over 1 minus 1, which would just be 0 over 0. And I cannot take 0 and divide by 0. So that would give me like a value that I basically cannot find the value of that guy, okay? Because I cannot plug him in. But all along the graph, everything else is continuous except this point right here where he just kind of like poops out. So what I do is I like squeeze in on either side and I find values going along this line on either side of that point until I get to that point and then kind of try to evaluate him, okay? So his x coordinate is 1, all right? I'm trying to evaluate at 1 on the x coordinate. So what I do is I create a table and I find values that are on either side of 1, okay? So I start by plugging in 0.75 because that's on the left side of 1. Then I plug in 0.9. What? 0.75? That's only 0.25 away from 1.
Why did you not start at like 0.99?
Okay. Probably.
I have a question.
What's that?
What is this used for? Like, what is this apply to? Like,
So,
good question.
that's a very good question.
So it's like
So we're trying to find the y coordinate for that.
not useless, but like
Is that what you're saying?
So like a hole in a graph a lot of times will be like the example that I use for a hole in a graph is, let's say you're paying a certain amount of money and you're going to a theme park, okay? So let's say we talk about the graph of just this chunk of the function, all right? You're paying a certain amount of money the going to a theme park, and the older you are, the more you pay, right? Like a 3-year-old is not going to pay the same amount as a 13-year-old. So the more, the older you are, the more you pay. But let's say it is your birthday exactly. You pay 0 amount of money, right? Because there's a hole there. Because it's on your birthday, you get rewarded. You pay 0 amount of money going to this theme park. Okay? It's like you get free ice cream on your birthday. Okay, so on your birthday, you pay 0 amount of money. That's kind of a hole in the graph. So basically what we're trying to find by looking at this point is we're trying to find how much money would you have paid if they didn't let you be free on your birthday. Does that make sense? We're trying to find the amount of money that it would have been if they didn't give you that discount. That's kind of a weird example of what we're talking about, ish.
So, point of view of
Yeah.
context.
So basically, you're trying to figure out, like, how much money did I bank by telling them it was my birthday, kind of. Like, how much money did I save by not having to pay anything, kind of.
This is
Like, we're
kinda
trying to figure out.
every single day of every single year.
What?
Is this like every single year and then that day's on your birthday?
Yeah, kind of, yeah. So what we're doing is we cannot plug in the number 1 into this equation exactly because we end up with division by 0, okay? So what we do is we plug in numbers on either side of 1. So we start with 0.75, we start with 0.9, 0.99, 0.9999, and Brooklyn says, why do you plug this one in? Because that's so far away from 1. Like it would just make more sense to plug in 0.9, 0.99, 0.999, whatever, okay? So maybe you only choose to do these 3 on either side, whatever, doesn't matter. The values that you get when you plug in 0.9 is 2.71, 2.99 is 2.97, 0.99999 is 2.997, okay? Those values look as though it's approaching 3, okay? On the left side, if I plug in 1.25, we get 3.81. If I plug in 1.1, which is a little bit closer, 1.01, 1.001, those values are getting closer and closer to 3 also. Does that make sense? They're pinching into that value, okay? So on my birthday, if I wasn't free, I would have paid like $3, basically. Does that make sense? That's the amount of money that I'm saving by it being my birthday, okay? Now, if I look at the graph, we can kind of see the way that this relates because what we're trying to find when we're trying to find the limit is kind of like the y-coordinate at that x-coordinate that poops out. So the x-coordinate that poops out is 1, but what is the y value at that point? If I look at the graph and I pinch him in this way and I pinch him in this way, he is approaching a y-coordinate of 3. Does that make sense?
Yeah.
So we would say that the limit, the way that this is written out, is the limit as x approaches 1, because that's the value he poops out at, of x cubed minus 1 over x minus 1. We would solve that and the answer would be 3. Okay? So this is what they will give to you as a question. They will say, evaluate the limit as x approaches 1 of this function. Okay, now looking at this again, we say we cannot physically plug 1 into this function because we'll end up dividing by 0. But if I look at the graph of it, it's pinching in toward, or look at the table, it's pinching in toward a value of 3. So the answer to that question is 3. Make sense? Ish? Weird? Okay? We're trying to find the value if there was a value. Basically. Okay? All right.
I don't like it.
I know. So this is the limit notation that they will use, kind of like what I had written over here. Okay? What they will ask you on this one, evaluate the function of this guy at several points near 0. So they are asking you to solve this problem. This is the way that they will give it to you. They will say, find the limit as x goes to 0 of this function. Okay? Now, what's the problem with finding the limit of 0? If I plug 0 in, I'll get 0 over the square root of 0 plus 1 minus 1. Okay, let's see what that comes out to be. 0 over the square root of 1 minus 1 is just 0 again. Can't do it. Okay, so we end up with a problem. I cannot physically plug 0 into the equation. So what we're doing is we're creating this table, which is going to show me on the left and the right side of 0 what that value is approaching. Okay, so on the right side of 0, okay, we were smarter this time. We did Brooklyn's method. We said, why would we start with numbers that are so far away from 0? So this time they're starting with 0.01. Then they're starting with 0.001, then 0.0001. Those are all getting close to 0. And I'm allowed to plug those numbers into this equation up here, right? Because it doesn't come out to be division by 0. And when I plug those numbers in, I get this guy, and this guy, and this guy, and those numbers look like they are approaching a value of 2. And on the left side, I plug in negative numbers like negative 0.01. And negative 0.001 and negative 0.00001. And those numbers are also approaching a y-coordinate of 2. So I say that if I were to be able to plug in 0, I'm not, but if I could, it would have a y-coordinate of 0. If they did not give me the discount of having it free on my birthday, I would have paid $2 or whatever.
Crazy.
Does that make sense?
Yeah.
Okay. If I look at the graph, this is what happens. There is going along till I get to this point, and on the right side coming in, the coordinate poops out right here at the point 0, 2. 0 is the x coordinate that it poops out at, but what is the y coordinate? It is 2. So if I'm evaluating the limit as x goes to 0 of this function, the solution to this guy is 2. That's what we're trying to find. Finding the limit is like finding the value of that point that does not exist.
So basically on our own, we just need to make that table and find whatever.
Yes, and I think they actually start you off with a table. Maybe. They tell you what to plug in.
So we don't
Okay?
actually have to do much.
Now, this one is an example of a piecewise function. This is the last example that we'll do, and then we'll stop. Okay, this is a piecewise function. And what this guy is saying is we have two equations. The first one says y is equal to 1 at all places, at all places except an x coordinate of 2. When x is not equal to 2, y is equal to 1. Okay? But when x is equal to 2, y is equal to 0. Okay, so let me show you what that looks like. Y equals 1. Y equals 1 is this line right, let me get a different color. Y equals 1 is this line right here. So at all other values of x, y is 1. Except at 2,
So there's a hole.
he poops out right there. Right? He has a hole right there at 2. And when x is equal to 2, where is the point actually living? At 0. So I'm going along, and then all of a sudden it poops out, that point drops down here, and I'm going along again. Okay? So an example of this would be, since my line is not slanted, like this one and this one, this would be a scenario where everybody pays the same amount,
And one person volunteers.
and on your birthday, you don't pay anything. Okay? So instead of this being a slanted line, like going up like this, and being a circle, and then going up, right? Everybody's paying the same amount, regardless of whether you're 3 years old or 53 years old. Everybody's paying the same amount. They're paying $1, except the person whose birthday it is exactly, they are paying $0. Does that make sense?
Yeah.
Okay, that's just a bad example, but it makes sense in this case. So, birthday, you pay $0. Everybody else pays the same amount. That's why it's not slanted. Everybody's paying the same amount. Okay, so there is this. All right, now, if I am trying to evaluate that point where that point does not exist, what would the limit of this guy be? They're going to ask me this. They'll say the limit as x goes to 2, because that's where he poops out at, of this function, I don't want that, 1, 0, x not equal to 2, x equal to 2. I'm writing that whole function in there. I want to know what this evaluated is, okay? So what would that value be if that value existed? What would that y coordinate be if the y coordinate existed?
1?
It'd be the same on one end.
What is that?
Which is 2, 1, whatever you go up.
So pinching in on this side
It'd be 1.
and pinching in on this side, the y coordinate should be, this should be the point 2, 1, right? So the limit is 1. Now, even though the point physically on 2 is at 2, 0, we're looking at what's happening on either side of that point. On either side, it's pinching in to the point 2, 1, so the limit is 1. Does that make sense? Okay, that's what we're trying to solve for. That's what we're trying to find. So coming in on either side, what is the y coordinate? Coming in on either side, what is the y coordinate? That's what he becomes. We really ignore this point down here. He kind of means nothing. We just analyze and look at what's happening on either side of the lines as it approaches that hole.
Okay.
Make sense?
Yeah, kind
Okay? All right? Because really I should be paying $1, but I'm not because it's my birthday. Right? It's what amount you would have paid if you are not allowed to be in free. That's the best example I can do of that. Make sense?
Yeah.
Okay? All right? We'll go over the rest of it tomorrow. Okay? Sounds good? All right. I know.